Welcome to Science Hub. You're watching Elimu TV. With you is Grace Wanjiku,
Jael Sempe,
Alana,
Anita Simavai from Namanga Girls High School.
Today, in this lesson, we're going to take you through physics under the topic Wave 1.
In waves, there are objectives which you should be able to define wave, state the characteristics of waves, state the wave formula, and solve problems involving wave formula.
A wave is a transmission of disturbance. There are two main types of waves, electromagnetic waves and mechanical waves.
Electromagnetic waves do not require medium of transmission. For example, radio waves, light and microwaves.
Mechanical waves are waves which require medium for their transmission. For example, light waves and sound, water waves and sound waves. Here with me, I have the water to experiment mechanical waves, which is if we disturb, we are able to see the waves which are formed.
Under mechanical waves, we have two types of waves. The first one is the longitudinal wave, which I have here. So, a longitudinal wave is a wave that it's the vibration of particles which is in line to the wave travel. Here, where it is more close to each other, we have the compressions, and where the wave is slightly apart, we have the rare functions. We also have the longitudinal wave, which is perpendicular to the wave travel.
In waves, we're going to focus mostly on transverse waves, and in transverse waves, we have the amplitude, which is the maximum displacement on either side. And its SI unit is in meters.
We also have frequency. Frequency is the number of complete oscillation made by a particle in 1 second. Its SI unit is hertz.
We also have period. Period is time taken to complete one oscillation. Example, in our diagram, we have, let's assume that we have 1, 2, 3, 4. Therefore, our period will be 4. Period stands for T.
We also have the wavelength, which is the distance between two crests or two troughs, where this is the crest and this is the trough. So our wavelength will start from here to here, or from this point to this point, and it is denoted as lambda.
In waves, we also have the wave formula, of which my colleague will help us to derive from it.
In the wave formula, we have velocity, which is distance over time. And the distance is simply the wavelength, and t is the period t, where t can be given as 1 over f, and the distance is lambda. We therefore substitute lambda with d and t with 1 over f, so as to get lambda over 1 over f, which in simple terms can be written as velocity is equals to lambda divided by 1 over f, getting our wave formula as lambda times f over 1, which is velocity is equals to lambda f.
In addition to that, for us to enable to understand this formula, we have a question which states that a water wave travels to 12 meters in 4 seconds. If the frequency of the wave is 2 hertz, calculate the speed of the wave. Speed, which is the same as the velocity, is calculated as distance over time. So V, the distance we've been given is 12 meters. in 4 seconds, which is the time. Calculate the wavelength of the wave. Here is the formula for the wavelength. V is equal to lambda, which is wavelength. We have the speed, which is 3. We are looking for the wavelength. And we have been given the frequency as 2.
Thank you for watching and stay tuned for more lessons.